Welcome to Inside Builder channel, Python experts, programming enthusiasts, and my dear friends. Grokking 4 data structures for excelling in problem solving. We shall look at the why and the how in 5 steps of grokking the data structures. So let's dive into the why first. And the logic with objects first of all becomes clear. The moment you try to work with the data structures, and if you have looked at my earlier videos in this series, I have been diving into the objects and how to create them, how to work with the turtle module and create real objects that can act on the physical world. So the logic behind the objects will first of all become much more clearer. Traversing connected objects becomes second nature. This point, traversing connected object, if it is new to you, then you are in for a treat. You are going to see a lot of ways in which we are going to use this traversing. Each repetition is one of the key aspects of the grokking concept. You are going to repeat and learn a lot about how you learn. So this is one of the key point that I wanted to highlight in this discussion. So you need to have a framework for your own learning when it comes to coding and problem solving understanding. So this particular exercise is going to provide you that opportunity. And visualizing the dynamic backtracking problems becomes easier. If you have come across some problem solving books or videos, and you have seen they talk about these dynamic problems, dynamic programming and backtracking, greedy algorithms and all those stuff, and if you were thinking that okay, these algorithms are extremely complex, once you go through this process of understanding the objects and why some things are done, then it is going to be way more easier for you. Okay, so this is the reason that I'm talking about. But what are we going to do? How are we going to really grok the data structures? So grokking is basically a term for understanding. It's more than understanding. You are actually going deeper into a particular concept and not just understand that concept. You are going to understand how you understood that concept. So it's kind of a recursive way of learning something. And this is one of the most important concept in coding as well as in computer science and implementation aspect. So kindly give time to yourself, relax and try to go through the learning process at your own pace, because in this fast moving world we always want to complete something in a given target, excel at a particular work and then move on to the next target. But in case of the problem solving, in case of the various algorithms, the data structures, the target itself is continuously moving. The moment you complete one technology, the new technology is going to come and replace it. So it is always better to learn the basics of the computer science, that is data structures, the algorithms, how the background algorithms works. That will really make you to stand out from the crowd. That is one of the reasons why I chose 4 data structures and not some 25 different data structures. Actually, there are 25 different data structures, and if you want to take a look, you can look at this particular resource. So in this particular link, which I'll be sharing in the description below, you can see all the various kinds of data structures that has been used, that can be implemented in Python, that is used in various computer science problems, has been listed here. And not just that, you can actually take a look at how what are the purposes of that each of the data structures, and followed that how in kind of what kind of problems that data structures is applied, and you can also see how it is implemented. So all these things are provided in this resource, so you can take a look at that. Going back to the presentation. So the idea is to take just 4 of the data structures, and the 4 data structures we are going to dive really deep, and we are going to first of all think how are we going to do that. So we are going to first of all visualize the operations that a particular data structure is going to do. In object oriented programming, the objects contain two things. It contains the data and it contains the characteristics of that particular object or particular uh, type of object. So object of type string has certain characteristics, object of type list has certain characteristics. These are called as methods inside object oriented programming. And the purpose of these methods, the purpose of attributes is the data. So if you are going to create an object, a class, a blueprint of an object, then you need to make it have an attribute and also make it have some methods. So that is how a class blueprint is written. If you have come from the ops, if you have read any of your earlier OOPS concept, you must have seen this. Every aspect of coding has a purpose. If someone is creating an attribute, they created it for a purpose. If someone created a method, they created it for a purpose, right? So as I was telling, attributes are to hold the data inside the object, and methods is to hold the characteristics of that object. So that is how we are going to think about objects. And then in this discussion, we are going to first of all visualize the operation first. If you are going to take a list data structure, so what are the operations that the list data structure can do? If you are going to take a linked list, what operations you want that linked list to do? All these things you can code. And before you code and implement the operations, you need to also know the pseudocode, or how and in what way we can actually implement that operation, and then implement it and write test cases for each operation. So this aspect of writing test cases is going to be pretty simple. You have to just create some print statements, but believe me, this also can become a challenge. If you don't know how to think about test cases, it's going to be extremely difficult to implement the operations, because you might implement something but you might miss some important aspect of the operation. So testing it thoroughly is also one of the important steps. And now comes the repetition process. So you start repeating these step 2 and 3 for 5 times. Yeah, you heard me right. You are going to implement the operations as well as write the test cases continuously for 5 times, again and again. But not just that, you are going to repeat it each time, and you are going to record a couple of things. You are not going to look at code and repeat it. You are going to implement it without looking at the existing code. So each time you repeat, you need to record how much you are able to implement, till what extent, whether you are able to visualize the operations, whether you are able to write basic class implementation, whether you got stuck in the method logic. You start thinking about how much you are able to implement, and then you also record what points you misunderstood and missed. The more you do this, the better you will start understanding the data structures. So this particular framework, you can use it for any kind of knowledge gaining process. There are a couple of challenges here. First and foremost, what if I am unable to visualize the operation? Second, how to know where the code for implementing these operations are? And finally, how to write test cases. All these 3 things you might be not aware of. You might be completely new to programming, and you may not even know the basics of it. If that is the case, then I would suggest you to take the basic programming courses, and take a book like Learn Python the Hard Way, and get used to the syntax of the programming language before you even think about implementing these data structures. And Also, it is better that you get your hands dirty with some kind of problem solving book. So you can try to work with Learn Coding Through Problem Solving book by Daniel Zingaro. It's one of the best books out there. And the moment you are comfortable with the basic operations of Python syntax, then you can think about this Grokking data structures. When it comes to the visualization, operation, and implementation, I am right now going to help you to work on the first two, the visualization and the implementation of the operation. So both of these things I am going to discuss right now. So, but before that, let me first of all introduce the data structures. The data structures that we are going to discuss are singly linked list, stack, queue, and graphs. Yes, these are the four major data structures that you can use it for a lot of different problem solving operations. And once you are comfortable with these four data structures inside out, then whenever you look at a problem that uses these data structures, you can immediately understand the algorithm behind it, even though it will take little more study of that particular problem, but the better part of the algorithm can be easily understood. So that's why I am concentrating on this. So let's dive into a couple of similarities and the differences of these data structures first. First similarity is all these data structures have nodes, and these nodes have a value and it has a connected node attribute. So what does this mean? Let's continue. It has got methods. So it has got methods like a connect method, print all nodes method, check whether it contains a particular value, a delete node. So all these methods or characteristics are available for this data structure. What are the dissimilarities, differences? How new nodes are connected? So this is one of the primary difference. How the new nodes are connected, like in stack, where the node, a new value is placed inside the data structure. How you traverse, meaning how will you move from one particular node to the another node. So that is the second major difference. Also, purpose and the problem solved. So this is also very different. All these things we will look in next couple of minutes. Now we need to think about nodes. So what is a node and how it is initiated? The node and its initiation is very straightforward. In a common node implementation in Python looks like this. It has got a name called, it has got a class with a name called node, and it is initiated with init method with a value and a next attribute. So these are the two attributes the node has. That is all. It does not have any other method. But if you want, you can add method to these nodes also. And you will see that in certain cases, in certain implementations, this node itself will become the complete data structure itself. So this simple looking class and the objects instantiated from this class can be very, very powerful. Just 4 lines of code is one of the most powerful implementation that you can ever come across. We will look at the example in a couple of minutes. Next, this is a common node that is available, that can be used for not just one data structure, it can be used for 3 data structures: singly linked list, stack, and queue. It's a very similar kind of a node that you can use for all these 3 data structures. But when it comes to graph node, a graph node is a little bit different. A graph node, or a node that is going to be used in a tree, or that is going to be used in a kind of a hierarchical situation, you will need a way to tell which particular path that particular node is located in, or the child node is located in this case. So that's where you get the self.write and self.left attributes. And look at this way of the way none has been assigned to the self.right and self.left, and in this case self.next. This is one of the basic heuristics. It's one of the ways to start learning, start making the problems easier, because you initially tell that the node that is getting created has by default a place for a next node, but the next node is none, meaning there is no any node connected. If this particular node is none, then you will automatically know that this node is not connected. So you can use this in logic. So that is the main heuristics that you have to understand from this particular design idea. Okay, when it comes to graph node, the graph node has three different ways of implementation. So you can implement the graph node with an adjacency matrix attribute. You can implement the graph node with vertex list attribute, and finally you can use adjacency list also. Okay, if you are not aware of these adjacency matrix list or vertex list, I would suggest to take a look at the Wikipedia, or I would like you to do a Google search. You will be able to get a treasure trove of details on these implementations, and you have to practice this inside out. Apart from that, the code that I'll be sharing also contains these things, contains the implementations of these adjacency matrix, vertex list, and adjacency list. I am first of all giving you an overview of what you need to look inside the node right now, and then comes the data structure itself. So when you are going to instantiate or initiate a data structure, you will create a class with the data structure name, and you will initiate it in case of linked list, in case of queue, and in case of stack. You will, in case of graph, you will initiate it with the head. So there will be a data structure, and that on the top or on the root of the data structure, you will have the head node, and this is going to be a node. And initially you will see that it is none. So you can initiate a data structure without giving it any value. So this def init method does not have any kind of parameters sent to it. So you can see that here. Same way, if you look at the node also, in case of node, you are sending a value, and that is getting assigned here. In case of graph node, you are sending a value that is getting assigned here. But in case of the data structure initiation, you are not sending any values. You can initiate a data structure that is empty. Here I have told self.size equal to 9, but when you are initiating, this is going to be 0. So here I have made this mistake intentionally. And then queue initiation is little bit different. In case of queue initiation, you are going to give both front and back, because the queue is going to contain the entry and exit at both the locations. So you need to know about this. Okay, then comes, you have seen how the DS is initiated, you have looked at how the nodes are initiated, and then we are going to look at how the DS is populated. You can have a database, you can have an Excel sheet, you can have a notepad that is filled with a framework, but how are you going to populate it? And how are you going to automate that population process? So data structure is first initiated, and then you think about a particular data, a list, a string, or it could be a list of another data structures also, another data types also. After that, you have to just loop over the individual elements of the list, and then use the connect method and populate the data structure. So you see this single line, this is the data structure instance, and this is the connect method, and you are going to send this ch element and connect it. That's it. So this is what is going to populate it. You might be thinking that, is this how the entire design process works? In fact, this is how it works. And when you are going to look at the various more complex scenarios, if you are not familiar with this kind of simple way of thinking, it is going to be much more challenging. So that's why I felt that we need to look at it. So here are the examples of how the data structures look. So the linked list is like this. So it is just a connected series of nodes. So you have A node, C node, K node. So it's a connected series of node, and it is connected in single direction. So A is connected to C, but the C is not connected back to A. So keep that in mind. I'm going to zoom in a bit. So you see the arrow mark going in one side, but not the other side back. So this is a singly linked list. And this is the head, and it has not got any tail, because you can keep on appending to the linked list. And you can keep on connecting to this linked list in any location. It's not that you have to append only at the end. You can connect a new node between C and K also. It is legal. It's not an issue. But how are you going to do that? That's going to be a question that you need to, that's going to be a logic you need to devise. And also you need to implement a separate method. Keep that in mind. When it comes to queue, there is going to be a front and there is going to be a back. When you are going to use a queue, it is the enqueuing process happens from the back. It is called as first in and first out. So enqueuing happens from the back, and the dequeuing happens from the front. So whichever element comes first gets pushed into the queue, and as it goes forward, it gets dequeued once it has been processed. So this is how queue works. And then we have stack. Stack has top and bottom. Stack is, we are going to push everything from the top only. So we are going to push from the top, and we are going to pull from the top, or pop from the top. As you start pushing, the element that is already present goes deep into the stack. So think about this particular dimension as the height, while in case of queue, this dimension from here, from left to right, is considered as the length of the queue, while in stack, from left to right, it is considered as the depth of the stack. The terms that you use, the terminologies inside coding is very, very important, because that is going to help you visualize the activity as well as the data structure themselves. When I say depth, it is going to be something that is having a height, and you are going to push something into it, or you are going to make something to fall inside that. That is how you can feel the depth, right? And same way, the length, a queue is something that is very long if the server is not working properly. And you have faced this day in and day out when your IP packets don't get delivered, when your internet is slow, because the queue is not getting served. And all those places, the queue data structure is getting used. And finally, we have graph data structures. So graph data structures start with the head, or in case it is also called as root. So the graph data structures, you can start with the head node, and then you have to give both the left and the right. Excuse me. So you can see that we can create left and right nodes, and these left and right nodes by themselves will have left and right nodes, and this goes on getting connected. Now we have seen the complete overview of the data structures. We have seen the differences, we have seen the similarities, we have seen how to the nodes are initiated, the data structure itself initiated, and how it is populated. But where is the code? How are we going to now that we have visualized the operation, then how are you going to implement it? That's where the resource is going to come into picture. I already have created this particular Grokking ds streamlit.app and made it public. This particular link will be shared with you guys. You have to go to this particular link and click on it. Inside that, you will see there is an overview where you will find the same thing that I explained, and there is something called as challenge register. And you will see that these are the this contains a list of dates and challenges. this is the list of the challenges that I faced in implementing the data structures on that particular day. So I have made a note of these challenges and I have placed it in this page. I don't want you to use this particular application directly. You need to go here and you can fork this app. And the moment you fork this app, it will fork this app into your GitHub account and your local environment. And from there, you can start playing with this app, and all the data inside that app will be private. Why I am telling this? Why this app has to be private? If you scroll down in this particular page, you can start adding your own challenges that you are facing. So the day I am making the video is on 25th, and whenever you are going to fork this app, on that day it will get updated, the date will get updated, and you can update the challenges here. So what are the challenges? If you go back to the discussion, I was talking about the time to record. So you can use that particular app that I have shared right now, that page that I showed, this particular page. You can start recording your progress. And each and every day, you will know what are the challenges you faced, what are the points you misunderstood, and you can keep track of it. In this way, you can learn by yourself. So this is one of the very important concept that had helped me a lot. And I have been using this idea for a long time right now, almost 1.5 years. And it gives you a lot of clarity and also gives a sense of purpose and direction. And all of these things, by your own, you can make it happen. You can become a self-taught data structure expert in no time. Now, this is one of the things. You ensure that you fork this app and then use it. If you don't fork it, then, and if you update it here, so if I, for an example, if I say this is an update on 25th Feb, you will see that it gets updated directly in this particular page, meaning that whomever has this particular link will be able to look at the update that you have made. So it's fine. You are going to share only the knowledge that you have learned or that you have got in by working on data structures. There is nothing private into this, but it is still something that I wanted to wanted you to understand. Continuing further, if you move to the implemented algo, so this is where the fun starts. Whatever you are looking here, it is a series of steps that you need to follow. So you have to first of all implement the node, you need to implement the linked list, then you need to implement all these methods. So if you scroll up, you will see that there are 4 data structures. So if you click on queue, the nodes will get updated. If you select stack, the nodes again will get updated. When you are beginning, just click on the stack node, you will see how it is implemented. You can click on the stack itself, you will see how the basic top level init method is getting written. And then you have the push, you have the pop, you have the print by loop, and you have get top. So all these things are provided, the code is directly provided here. And when you are going to when you are going to do it for the first time, you are going to visualize the operation, then you are going to implement the operation, right? This implementation process is already done here. What happens next is more important. Okay, you can click on show node. So in case you want to look at the entire node, just click on this show node. So it will show the code in all the expanders. The important point is that writing the test case. So you need to first of all know how to write the test cases, and for that I am going to leave it to you. I want you to think about how you can write test cases. And all these three things you are going to repeat it 3 to 5 times. And the more you are able to repeat it and the more you are able to succeed, the better you are able to understand the data structures. So that is the idea of this entire application as well as this entire process. The more you are able to, you can also add new algorithms here. You can create new algorithms, you can name the class, you can provide the various methods, you can add that and you can submit it. And once you submit it, it will get updated in this particular stack, in this particular list. And you can take a look at this. And in fact, this particular application has been written in Python. And the same idea of the implementation that you are looking at here, it was first visualized, it was then implemented, and a lot of test cases were run. And that is how this app was created. It might look complicated, but at the back end, this app is using a simple JSON file to store the data and to retrieve the data. A simple file that contains curly braces and data inside it with list is doing all this stuff. There is no database involved. So once you understand how the technology works, you can do a lot more stuff. So right now I'm going to end this video, and I would suggest you guys to take a look at this process first of all, why and the how, and try and implement the various data structures that we saw, these 4 data structures, and follow that by implementing the nodes, implementing the data structures, and trying to populate it in this way. If you look at the data structures, all the data structures will have a way to push. In this case, there is a way to push the value. In case of stack, if you go to linked list, there is a way to append the value. So you will not have a method called as connect. If you go to graph, so there you will have connect. So you are going to connect to the graph. But in case of other data structures, you might have NQ, Q, that is NQ and DQ, and push and pop, append and delete. So these are the various methods that you need to look up and start implementing, start trying to comment out. So each and every code, once you start writing, comment it out. The more you comment it, the better you are understanding it. And then keep track of your challenges and also the knowledge that you are gaining in this particular page. So in a week, if you are trying to work on 4 days or 5 days on these data structures, and by the end of the week, when you look at it, when you read it, you will see how much you have learned. So I believe that you have learned a lot in this discussion, and once you start implementing it, you will find it's very, very useful, and it's going to change the way you understand the logic, you understand how to implement certain heuristics or certain ideas in coding, etc. So do take a look, do subscribe to my channel for similar kind of videos, and do leave a like to this video. If you have any questions or queries, do leave a comment. With that said, I would like to leave the video with 4 words, that is practice, practice, grok, grok. See you guys. Have a great time.